Hello everyone and welcome! So today, we're diving into a really crucial chapter for your exams, triangles. Now I know this topic can sometimes feel a bit tricky, but don't you worry, we're going to break it down step by step and make it super simple. Let's get started, shall we?
Okay, so to get our brains warmed up, let's start with a little question. What do two ATM cards from the same bank, two 1 rupee coins, and, two of your own passport photos all have in common? Just think about it for a second. I mean, if you placed one right on top of the other, they'd match up perfectly, wouldn't they? They are identical copies. And, you guessed it, in math, we have a special word for that very thing.
So, here's our game plan for today. We'll start with what congruence is. Then we'll get into the SAS congruence rule. After that, we'll see it in action with an example, use something called CPCT, and finish up with a recap and a very important exam tip. All right, let's dive right in.
Okay, first things first, congruence. Let's really get a solid handle on what we mean when we say two figures are, identical.
So, what are congruent figures? Well, it's pretty simple, actually. They're just figures where the shape and the size are both exactly the same. The textbook phrase is equal in all respects, which is just a fancy way of saying if you could pick one up and put it on top of the other, it would cover it completely, no bit sticking out. Think of them as perfect twins, exact copies of each other.
And believe it or not, you see congruence all around you in your daily life. Seriously, think about two Bengals of the same size, or those ATM cards we were just talking about. Even two 1 rupee coins minted in the same year. Or how about the molds in an ice tray? They're all congruent so that every ice cube comes out looking exactly the same. It's a super practical idea when you think about it.
Okay, now, this next bit is super important. I need you to remember this acronym, CPCT. It stands for Corresponding Parts of Congruent Triangles. Now, why is this so powerful? Well, it basically says that once you've proven two triangles are congruent, you automatically get to say that all their other matching parts are equal too. The leftover sides, the leftover angles, all of it. So keep this little tool in your back pocket. Trust me, CPCT is the key to solving the second half of so many geometry problems. We'll see exactly how in just a minute.
So does this mean we have to measure all 3 sides and all 3 angles every single time? That's 6 different things. Thankfully, no way. Math has some really clever shortcuts, or rules as we call them, and the first one we're going to look at is the SAS congruence rule.
The SAS rule is actually really straightforward. It says two triangles are congruent if two sides, and now listen up, this is the most important part, the included angle of one triangle are equal to the two sides and included angle of the other. What does included mean? It means the A for angle has to be literally sandwiched right between the two S's for sides. That's why we call it side angle side, or SAS. And this picture shows exactly what I mean by included. Look at that. See how the angle is literally formed by the two sides we care about? It's trapped right there between them. If the equal angle was somewhere else, say one of the other corners, then the SAS rule just doesn't work. This is probably the #1 mistake students make, so please always double check. Is the angle between the two sides?
The best way to really understand a rule is to actually use it, right? So let's tackle a typical exam question together step by step. We'll go through it nice and slow. You've got this.
All right, here's our problem. We've got this figure where two lines, AD and BC, cross each other at point O. Now we're given two pieces of information. First, that side OA is equal to side OB, and second, that side OD is equal to side OC. Our first job is to prove that triangle AOD is congruent to triangle BOC.
Okay, so whenever we start a proof like this, we first state which two triangles we're looking at. So in triangle AOD and triangle BOC, let's see what we've got. The problem flat out tells us that OA equals OB. Perfect. That's our first side. Let's put a check next to that.
All right, next up we need an angle. The question doesn't give us any equal angles, does it? But wait a minute, watch carefully. Look at the diagram. Angle AOD and angle BOC. What are those? They're vertically opposite angles, and we know that vertically opposite angles are always equal. Yes, that's our angle. Another check. And for our second side, well, the question also gives us that OD is equal to OC. That's our second side. And check.
So let's just take a step back and see what we've got. We have a side, OA equals OB, then we have the angle that's included between them, angle AOD equals angle BOC, and then we have another side, OD equals OC. We have side angle side. So, therefore, we can officially say that triangle AOD is congruent to triangle BOC. Why? By the SAS rule. And just like that, the first part of the question is done. Solved.
Awesome. So we proved the triangles are congruent. But so what? Why does that even matter? Well, the second part of the question asks us to prove that the line AD is parallel to the line BC. And this is where all our hard work is going to pay off. Let's see how.
This is where we get to use our secret weapon, CPCT. Remember what that stands for? Corresponding parts of congruent triangles. Now that we know the triangles are congruent, we can say that their other matching parts must also be equal. So that means angle OAD has to be equal to its matching partner, angle OBC. And what's our reason? It's as simple as writing by CPCT.
Okay, now look really closely at the diagram again. Do you see the Z shape? If you trace from D to A, then across to B, and then to C, it forms a sort of Z. The two angles we just proved are equal, angle OAD and angle OBC, are what we call alternate interior angles. And what's the rule about those? If you have a pair of alternate interior angles that are equal, then the lines they're between must be parallel, which means AD is parallel to BC. And that's it, we're done. See? Not so tough once you break it down.
Fantastic work, everyone. Let's do a super quick recap of what we just learned. And I'll leave you with one really important tip for your exams.
So here are the three main things to take away from this. Number 1, congruence just means same shape, same size. They're identical. Number 2, the SAS rule. It's a great shortcut, but you have to remember the angle must be included between the two sides. And number 3, CPCTC. That's your go-to tool after you've proven congruence to find out what else is equal.
And now for that exam tip. Please be very careful about this. It's a common mistake alert. SAS works, right? Side angle side? But what about SSA or, well, ASS, where the angle is not in between the two sides? That does not work. It will not prove that triangles are congruent. This is a really common trap they put on exams, so you must always check that your A is between your two S's.
And that's really all there is to it. Great job today. You've now got a solid handle on one of the most important rules in all of geometry. The key, like with anything in math, is just to practice. Keep working on these kinds of problems, and I promise you, you'll start to see that geometry is just like solving a fun puzzle. You'll be acing these questions with confidence in no time. Thanks for joining me.